Hi, and welcome back to my YouTube channel. In this video, I'm going to be showing you how to perform an independent sample t-test. If you watched my other video on one-way analysis of variance or ANOVA, you probably know how to perform an independent sample t-test. So, an independent sample t-test is not so very different from an ANOVA because in the one-way analysis of variance, we have an independent variable with three or more groups, whereas in a independent sample t-test, we have an independent variable with two groups. That's the only difference. Okay. Now, when we look at independent sample t-test, it is a parametric test, which essentially means that you have to have normality before performing the test. So let's go ahead and check the normality of this particular case, and then we'll go ahead and perform the independent sample t-test. So the first thing we're going to do is we're going to look at the level of depression and indebtedness. We want to find out whether the level of depression of the respondents is affected by indebtedness, that is borrowing of loans. Okay, so we want to see if people who have borrowed loans are more depressed than those who have not borrowed loans. Now let's go ahead and perform the test. But before that, let's go ahead and check for normality. For this, we need to go to analyze, we need to go to regression, we need to go to linear. Okay, now here we need to select the dependent variable, which is depression. This is depression 2. We put it in the dependent column, and in the independent column we will put the indebtedness variable. Okay, this is the one, whether the family has borrowed any loans, indebtedness of the family. Then we click on save. We select the residuals. Okay, we want these residuals. Then click continue and click OK. Now we are now going to look at the output. We are going to go to the dependent, data view, and here you can see a new variable would have been created at the bottom, which is the residuals. Okay, this is the newest variable we have created. Now this is what we need to check for normality for before going ahead with the independent sample t-test. For this, we click on analyze again for checking the normality. We go to descriptive statistics. We select descriptives. Scroll down. We select the residuals. Put it in. Select Kurtosis and Skewness. Click on OK. Now we go to the output. Now here we see the kurtosis and skewness values. Okay, so what we need to do is we need to divide the kurtosis value by its standard error and the skewness value by its standard error, which is 0.83 kurtosis divided by the standard error, which is 0.66. We get a value of 1.25. Now this is well within the 1.96 level that needs to be there for a 50 sample data file. Okay, so that therefore we can say that the kurtosis isn't an issue. Now let's look at the skewness value, which is 0.84 divided by the standard error, which is 0.34. When we divide both of them, when we divide that, we get a value of 2.47. Now this is slightly higher than the expected value for normality. Okay, normally we expect a value of about 1.96. Now, since we do not have normality in this case, we should technically not be performing the independent sample t-test. However, for the example's sake, I will be going ahead and performing the t-test. Okay. Now, for this, we need to go to the data file again, go to analyze, go to compare means, and select independent sample t-test. Now here we select the two variables. One is the indebtedness of the family, that will go into the grouping variable, and under the test variable we enter the depression variable, which is a continuous variable, by the way. Okay, this is a continuous running number. We put it in. Then we define the groups. The first one would be yes, that the family is indebted, and the second one would be no. Then click continue. Right, so now we have yeah, we have the data here. We just click OK and go to the output file, and we find the results over here. Here you can clearly see that there is a statistically significant difference in the result, so therefore there is something of great value here. And if you look at the mean score, it's quite clear. Those who are from families where they are indebted, that is where they have borrowed loans, we see that the mean score is higher of depression. It's 13.78 versus 7.48. So this means that those who have borrowed loans are more depressed, or who come from families where there has been loan borrowing going on, they are more depressed, and the results are statistically significant. Okay. Now, how do we interpret all this? I have a small uh, interpretation going on here, which could be useful for you. I put all of this in a table. Okay. So the table is titled Independent Sample T-Test, Indebtedness and Depression. As observed in Table 1, those who have borrowed loans have a higher mean score of depression compared to those who have not. Very simple. Furthermore, the results have turned out to be statistically significant at a very high level in this regard. P is less than 0.001. Thus, the research hypothesis that there is an association between the indebtedness of of the respondents or family and depression is accepted. Okay, so this is how you interpret the entire uh, results as well. I hope you found this video useful. Please remember, in the case of skewness, I did not get normality. The data is skewed in one way or the other. So therefore, technically this should not have been performed. So please make sure you have normality. In case you do not have normality, you can go for non-parametric alternatives like Kruskal-Wallis test, for which I also have a video. I will leave it in the description. Okay. So thanks for watching, and bye for now.